Kia ora boys, welcome to the 2018 practice exam work solutions, Nelson College. Alright, question 1. Wiramu, Tioni and Atoa each have a rectangular garage. What is the area for Wiramu's garage? Okay, so here's Wiramu's garage. So what we're really asking you to do is to expand the brackets, because this length is 3x minus 1. This length is x plus 4. That's what we're asking you to do. So this 3x squared, negative x, 12x, negative 4. So expression for Wiramu's garage, 3x squared minus x plus 12x minus 4. So if I can simplify that, because I've got some like terms there, I've got 3x squared plus 11x minus 4. In this question you'll get your achieve mark for correctly expanding and simplifying that expression. Okay, so here's Tioni's garage. Again, we've got another rectangular garage where this is 3x, that is negative 2. So now we're trying to expand that. So we've got 3x squared there, we've got 6x, we've got negative 2x, and we've got negative 4. So an expression for Tioni's garage is 3x squared plus 6x minus 2x minus 4, which again, adding the like terms, gives you that there. Now, the question is asking you to find the difference between areas. Okay, so here is Tioni's. Wiramu's from the previous question, 3x squared plus 11x minus 4. The difference between Wiramu and Tioni's, so Wiramu's minus Tioni's, is 3x squared plus 11x minus 4. Wiramu's minus Tioni's, 3x squared plus 4x minus 4. That gives you a difference of 7x. That mark there is a merit. So you'll get your achieve by calculating Tioni's. You get your merit by giving me the answer there, by correctly expanding and finding the difference. Okay, so here's now Natoa's garage. It has an area of 36. So again, we've got this rectangle, x plus 4. So in other words, we've got this rectangle where we've got 2x plus 7, and we've got this x plus 4 length, and this area equals 36. So 2x squared, 7x, 8x, 28. So 2x squared plus 8x and 7x, that is 15x, plus 28 equals 36. There is the expression for Natoa's garage. It has an area equal to 36. Now that's a quadratic equation. To solve a quadratic, we have to make it equal 0. So now we've got 2x squared plus 15x, 28 minus the 36 gives you negative 8, and that equals 0. Okay, so now that it equals 0, what we have to do is factorize that. Okay, so that one's a hard one to factorize because we've got this 2 out the front. Now, I'm not sure how your teachers have told you to do it, but what I tell my boys is to have, well, here is the expression. What I tell my guys to do is to go 2 times the negative 8. That gives me negative 16. So now that is the number that I'm looking for, where the factors of negative 16 that add to positive 15. Now to me, that's going to be positive 16 and negative 1. What I'm going to do now is I'm going to rewrite this positive 15 in terms of these two factors. So 2x squared plus 16x minus 1x minus 8 equals 0. That's still the same expression, isn't it? Okay, so what I'm going to do next is I'm going to factorise these first two terms. What's common between 2x squared and 16x? Well, 2x. And 2x goes into 2x squared x times. 2x times 8 will give me the 16x. Now, here is my bracket that needs to be exactly the same over here. But this part here needs to be equal to negative x minus 8. So what do I have to multiply x plus 8 by to give me the negative x minus 8? And the answer is negative 1. So now what I've got is an expression where this part and this part form one bracket and x plus 8 is the other bracket. This is all equal to 0. The reason why, remember, if this was just an expression, I could expand this. I would do 2x times there times 2x times that. In other words, I'd do that times that. And then I'd also do that times that and that times that. In other words, I'd do that and that. So it's the same thing, it's just written a different way. It's the easiest way to explain it. Okay, so from there, I've got x is equal to negative 8 or 1/2. But x cannot equal negative 8, so x is a half because you can't have a negative length. So from there, what we need to do is we need to make sure we find the dimensions. Yeah, so we just got to remember to find the dimensions of the garage. So if x is a half, then this length here is just 4.5. If x is a half, then that is 1 plus 7, that's 8. So the dimensions of the garage are 4.5 by 8 meters. To me, there are lots of ways of doing this particular question, but it does look pretty tricky. So what you need to do is remember back to your basic algebraic skills. X squared times x cubed, we all should know, is x to the power of 5 because we can add these indices. Because we've got the same base, we can add the indices. If we've got, if we're dividing things, then hopefully you'll understand that you subtract those indices. And if you are raising things to the power, then you will multiply those indices. If you can understand that, apply it over here, then you're not too bad. First step is to write everything as the same base, because over here we needed things to be the same base. And if you remember, 27 is 3 times 3 times 3, so it's 3 to the power of 3. So let's write this down in terms of 3. So 3x plus 2 times 3 to the power of 3 x minus 1, all divided by 3 to the power of x minus 2 times 3 to the power of 3 x plus 1. Excuse me. So understanding this rule here now, what these other two, what they are going to be, what we're going to equal here is going to be 3 to the x plus 2, 3 to the x minus 2. This top line is going to be times 3 to the power of 3x minus 3. The bottom one's going to be 3 to the power of 3x plus 3. Now what we try and do is let's do this times. Let's do each line. So now it's going to be equal to 3 to the power of x plus 2. So 3 to the power of x plus 2 plus this 3x minus 3. And we're going to divide that by 3 to the x minus 2 plus 3x plus 3. Simplifying those, we're going to get 3 to the power of 4x minus 1, all divided by 3 to the power of 4x plus 1. Right, now let's try this one, where we're going to get 3 to the power of 4x minus 1 minus 4x plus 1. and we're minusing the whole thing. So that now becomes 3 to the power of 4x minus 4x is 0. Negative 1 minus 1 becomes negative 2, which is, of course, 1 over 3 squared, which is 1/9. So with this particular question, a very hard question, let's have a look at where we get our marks. So if you can do this step here and turn things into the base of 3, there's your achieved tick. If you can get down here and talk about this is a merit, and then down here your answer is an excellence. So to me, you're sort of talking about one step is your achieved tick, 2 steps is your merit tick, and your excellence tick is your answer. Okay, so t is equal to that, values of n where t is less than 5. So let's set this equation up. T is less than 5. That's the expression. Again, that's a quadratic. First things first, let's make it equal 0. Or in this case, make it less than 0. To do that, what I did is I took 5 off both sides. Now, this is just a graph, okay? So this is just a parabola. What we're trying to do is, where is it less than 0? Where is it less than 0? Now, it's less than 0 between these two critical points. So let's find these, what we're going to call critical points. We're going to find and solve this particular equation to be equal to 0. Again, this is quite a hard quadratic to factorize. Negative 3 times negative 8, negative 24. Factors of negative 24 that add to 10. That's positive 12 and negative 2. So I'm going to rewrite this as 3n squared plus 12n minus 2n minus 8 equals 0. I'm going to factorize the first part. Common factor is 3n into n plus 4. I want that bracket to be exactly the same. To get, I have to multiply this by negative 2 to get me that top part. Now remember, therefore, this is one bracket, 3n minus 2, lots of n plus 4, all the while this is equal to 0. From here, what I'm getting are two solutions of n is negative 4 and n is 2 over 3. We are solving 3n minus 2 equal to 0. Add 2 to both sides, divide both sides by 3, and you get n is 2/3. So negative 4 and 2/3. These are my critical points. So where is it less than 0? Between. So this graph here is less than 5 between negative 4 and 2/3. Algebraically, you should be able to say that there. Alright, so where do you get to? What they wanted you to do is get to about here for an achieved. Be able to understand that you make it equal 0. That's what I would expect for an achieved. For a merit, I want you to be able to solve that particular equation. For an excellence, understand what your solutions, your merit actually means in the question. Okay, so this one here, we're talking about an isosceles triangle that Whittaker draws. The sum of the 3 shortest sides, so the 3 shortest sides being this one, and this one, is 8 centimeters longer than the longest side, so this one here, plus 8. So the sum, adding these 3 together, 2x minus 1 plus 2x plus 3 plus 2x minus 1 is the same as the longest side plus 8. Okay, so here are the sides. There's the first side, there's the second side, there are the third side. The isosceles trapezium just means these two are the same. Okay, now we just got to, excuse me, just collect those like terms and solve that linear equation. On the left side, we've got 6x, negative 1, that's negative 2, plus 3, that is plus 1. That equals 5x plus 8. Now what we're going to do is we're going to subtract 1 from both sides and subtract 5x from both sides. This leaves us with x equals 7. Question 2a, that there is an achieved mark and you needed to get the 7 for your achieved. Sorry, achieved, not an R. It should be a U tick. Okay, next question, B. I think you're overthinking this one potentially a little bit too much. All we're talking about here is finding the area of a triangle. So the area of a triangle, remember gentlemen, is just a half times the base times the height. So here's my base, here's my height. So this area of this triangle is just a half times 3x plus 2 times h. It just so happens that this area actually equals this part up here. So if we write it down over here, 3x plus 2 times h equals 15x squared plus 7x minus 2 all over 2. I can understand you're getting a little bit confused by this, but this here just means a half. So let's ignore that and ignore that. So now what we've got is really just 3x plus 2 times h equals 15x squared plus 7x minus 2. In other words, factorize that into these. Now we've already got one factor, so h therefore is going to be whatever 3x plus 2 multiplies by to get 15x squared plus 7x minus 2. Now if I'm expanding this, that times this one is going to give me 15x squared. So it needs to be 5x. And this one times this one gives me this one. So it has to be negative 1. Double check. 3x times negative 1 is negative 3x. 2 times 5 is 10x. Does that equal that one? Yeah, it does. So my height is 5x minus 1. Okay, that's that's the height anyway. Now, what do you know? What does this tell you about the triangle? Especially for the value of x. Well, what it means is my two factors here. This length has to be positive, and so does that have to be positive. So 3x plus 2 has to be greater than 0. Okay, so in other words, 3x has to be greater than negative 2, x has to be greater than negative 2 over 3. And the other one, 5x minus 1, has to be greater than 0. So again, so 5x has to be greater than 1, so x has to be greater than 1/5. I think I said that right anyway. So if we plot those on a number line now, here's 0, there's 1/5, there's negative 2/3. This solution says x has to be greater than that. This solution here says x has to be greater than that. Where do both happen to exist? Well, both happen to exist here. So x has to be greater than 1/5 to ensure sides are positive. Again, you got achieve, merit and stuff through here. So to me, if you're able to form an equation along those lines, that should be your achieve mark. Actually, let's go with this one down here. You can get a merit by giving me that correct height, that simplified expression to provide the height. Down here, next question, if you're setting up the two conditions, so if you're setting up this one and this one, there's your achieved. If you can solve them to give me that and that, there's your merit. Your excellence is actually understanding that it has to be the greater than the 1/5. Okay, so Newton's law of gravitation is given by this formula. What it's really asking you to do is say G equals what? So if we've got this expression, F equals negative G m1 m2 all over r squared, we've got to do a few steps. So let's do it. First step, let's times both sides by r squared. So we get F r squared equals negative G m1 m2. The next step, let's divide both sides by m1 and m2. This gives us F r squared over m1 m2, and this is equal to negative G. We want it to be G, so let's just divide both sides by -1, or in other words, just make the negative on the other side. Gives us an answer of negative F r squared over m1 m2. This particular question gives you a merit. So if you can make 2 steps towards what your solution should be, there's your achieved. Get the final answer, there's your merit. Okay, so let's have a look at this particular question. We got Tioni is currently 4 times older than his daughter, and we're going to try and figure out his age or her age actually. We've got to figure out her age. What we do know is that 5 years ago he was 9 times older than his daughter was. So first of all, let's go let T equal Tioni's age. Oh, can't spell age. Delete one of those A's. Now, and D equal his daughter's age now. Now we've got a couple of equations. So Tioni's age is daughter's age times 4. 4 times the daughter's age is Tioni's age. 5 years ago, so Tioni's minus 5 years ago, 9 times older than his daughter was. So daughter was 5 years old, no, sorry, 5 years younger, and there it is 9 times her age. So there are my 2 expressions. Now what I'm going to do is I'm going to get rid of this question. I'm going to expand these brackets. So T minus 5 equals 9D minus 45. Now I'm going to, just expand those brackets there. Now I'm going to add 5 to both sides, and what I've got is T equals 9D minus 40. So T and T equals and equals. So in other words, 4D, which is the same as T, is the same as 9D minus 40, because that is what D is the same as. Now let's rearrange this. Let's add 40 to both sides and take away 4D from both sides. This gives me 4T equals 5D. Now what I'm going to do is I'm going to divide both sides by 5, which gives me D equals 8. Daughter's age is 8. If D equals 8, T equals 4 lots of 8, which is 32. Good practice just to solve both solutions. Question is, how old is his daughter now? Write in words, daughter is 8 years old now. So again, we got some pretty good marks here. Just trying to find the marking schedule for that particular question. Right, from memory, if you're able to form one of these equations, there is your achieved. Just one of them, there is your achieved. If you can form both, is your merit. So both equations. Your excellence should come from working it through, giving me the answer, understanding what you're doing. That is from memory, so double check that with your teacher. So Widomu launches a projectile from the ground level. Flight path projectile can be represented by that. X, horizontal distance. H, height of the projectile from the ground level. how high, so in other words, h is what, when the horizontal, when x is 2. So what is this when this is 2? So h equals 5 lots of 2 minus 2 lots of 2 squared. It's x squared. So that is 10 minus 2 lots of 4, which is 8. So 10 minus 8, 2 meters. What is a horizontal distance? So what is x when h first reaches 3? So when h is 3 first. So h is 3 equals 5x minus 2x squared. Now, I like dealing with positive x squareds. So we're going to add 2x squared, and we're going to subtract 5x from both sides, which gives us 2x squared minus 5x plus 3 equals 0. Remember, to solve any sort of quadratic, we make it equal 0. Okay, so now we're going to factorize this. Should do it the same way as you've done before. 2 lots of 3 is 6. Factors of 6 that add to negative 5 is negative 6 and 1. Alright, but because I can see this and I've done it before and I've got the answers in front of me, I can see this answer and it's factorized. It should be 2x. Can I see this answer? Minus 3 and x minus 1. Double check that. 2x squared minus 2x minus 3x is negative 5. Positive 3. Yeah, perfect. So there is my solution. Well, that's my factorized answer. Now, next step, I need to solve that. So x equals x equals 1, or 2x minus 3 equals 0. So 2x equals 3, or x equals 3 over 2, which is 1.5. So where is it first 3 meters? Well, x equals 1. If you think about this, this is just a projectile, so it's just going bang like that. That's what it is doing. Okay, so the first time it reaches that 3 meters is 1. Now, answers here. So you get an achieved. You get your achieved if you can tell me this 2 meters. You also get an achieved if you can get to this part here, if you can factorize that expression. Okay, if you can factorize and solve it and identify this part here, there is your merit. Okay, so this question is interesting because the way I did it, nowhere near the way they did it. What they wanted you to do is to go, well, times both sides by 4 to cancel that part there out, and times both sides by a minus b to cancel that part out. It gives you 4 lots of a plus b equals 5 lots of a minus b. Expanding those brackets, 4a plus 4b equals 5a minus 5b. Rearrange things, take away 4a from both sides, add 5b to both sides, and you're going to get 9b is a. Now if a is 9b, then a squared is just 9b squared, and b is, or b squared is just b squared. That is 81 b squared all over b squared, so that answer is just 81. The way I did it, do it in purple, the way I did it is I said, well, a plus b equals 5, and a minus b equals 4. So if I add those, like two simultaneous equations, add those two expressions, I get 2a, the b's cancel, is 9. So a is 4.5. Now if a is 4.5, b is 0.5 from that first equation. Okay, therefore that makes a squared over b squared, it makes it 4.5 squared over 0.5 squared, which is, without a calculator, quite hard to do, but I would have said 4.5 is actually 9 over 2, which is 81 over 4. So 4.5 squared is 9 over 2 squared, which is 81 over 4, which is 20.25. Half squared is just a quarter, so it's just 20.25 over 0.25, which is 81. Okay, so from here, if you're able to form this linear expression, there's your achieved. If you can give me the answer, there's your merit. But I think you should also be able to say, if you can identify the two simultaneous equations, that should be achieved as well. And if you can get me your answer, there is your merit. The key is you had to use algebra to get the 4.5 or the 0.5. You can't just guess. Okay, it's not a guess and check thing. You need to use algebra. The name of the paper is use, or actually apply algebraic procedures to solving problems. Okay, so back to Tione and Natawa, they're now investigating the properties of consecutive whole numbers. So, and we're actually investigating the difference that two consecutive square numbers is always an odd. Okay, so let's go. Let x and x plus 1 be our two consecutive whole numbers. So now the difference between those square numbers, so x plus 1 squared minus the first one squared, what they're saying is equal to an odd number. We need to prove that. So let's expand that bracket. X plus 1 minus x squared. Let's just expand that bracket using Kirby-Napadal method. X squared plus x plus, so that's plus 2x plus 1 minus x squared. Now, if I'm correct, then that minus x squared and that x squared will cancel, which leaves us with 2x plus 1. So we're talking now the difference between two odd, so the difference between, between two consecutive square numbers is 2x plus 1. It's the first number times 2 plus 1, that's the difference. Now, if you think about that, then an odd number times 2, so 3 times 2 is 6, 5 times 2 is 10. Any odd number times 2 is an even number. So since 2x is even, 2x plus 1 will be odd, always, because it goes even, odd, even, odd, even, odd. That there is, again, that what they're saying there is that is an excellence question. So if you can set up this equation here, there is your achieved. If you can establish the difference is 2x minus 1, then that is a merit. If you can set up the expression, establish it's 2x plus 1, and then clearly justify why it is, so and over here, that is your excellence. And finally, it might be the last question in the paper, and it might not have any sort of maths numbers or anything in it, but this question, if you can access it, can be achievable. So we started looking at what happens when you take any whole number, so that's x, multiply the number below, so that's x minus 1, by the number above, x plus 1. Now Todd thinks he found a relationship between three consecutive whole numbers, or these three consecutive whole numbers. Alright, so if we go x minus 1, the number below, we multiply that by x plus 1, we get x squared plus x minus x, well that cancels, negative 1 times 1 gives you minus 1. Well, what that says then, the product will be x squared minus 1. So the relationship is when you multiply 3 by 5 will be 4 squared minus 1. 15 equals 16 minus 1. Yeah. So there is a relationship there. Again, and investigate the relationship. So we've done that once. Let's have another crack. Let's choose 10. 9, number below, times number above, 11 is 99. 10 squared is 100 minus the 1, 99. It's true. So there is the relationship. Okay, so where do you get your achieved merit and excellence from? So if you can correctly form an expression, so if you can get this part, there is your achieved. If you can get to this part and correctly form the expression for the difference, and it's not quite a complete description, then that is your merit. The full description is an excellence. So that there's not a very good description, but what you could have said was, when you multiply number below by number above, you get the number squared minus 1. Hopefully that sort of makes sense. I haven't done it very good because I'm just trying to make it very quick, but there's your achieved merit and excellence on that question. And to be fair, if you can understand those words, doing something like that there should be something that we can access. Make sure you try every question in the paper, because I believe some of you might have let yourselves down by that.